Here are solutions to quiz number 7 for ECE 320. This quiz covers DTL and TTL logic. The first problem is a DTL OR gate. If you have these inputs, what are the voltages and currents? Now, starting out, I've got these three diodes. This is a max function. The highest voltage wins. So this diode turns on, the other two turn off. Makes this 10 minus 0.7, 9.3 volts, and that's a check. I'm trying to push current backwards through the second diode, it turns off. Push current backwards through the third diode, it turns off. So this one's turned on. I've got now 9.3 volts. I lose 1.4 volts across these two diodes. So the current is your 10 minus 2.1. Again, 10 volts. I've got three diodes in series. Divided by R. In my case, that's 1314 ohms. I2 is 6 milliamps. Now, if the current gain is 100, that allows 600 milliamps to flow. I'm only trying to push 10 milliamps, so this saturates. When saturated, it's 0.2 volts. These diodes, I need 2.1 volts to turn on. I've only got 0.2, so these two turn off. I4 is 0, and then by voltage division, it's 2K over 2K plus 400 times 5, 4.167 volts. Problem number 1. Going on to problem number 2. In this case, this is a min function. This is an AND gate. The smallest voltage wins, which is going to be the 0 volts. That makes this 0.7. And it's actually the smallest of 3. I've got 1.4 volts. Well, actually over here, this is 0.7. The smaller between 0, 5, 10, and 0.7. 0 wins. So all these are off. I2 is 0 milliamps. When this is off, I have 5 volts. There's no place for the current to go, so current is 0. I get 5 volts of V3. I now have this path to ground. So 5 minus 1.4 over R, this is 1314 for me, gives you 2.74 milliamps. That allows beta 100 times as much. Allows 274 milliamps. I'm only trying to push 10. So this saturates. V5 is 0.2 volts. Problem 3, this is open collector logic. If I have 5 volts, that turns on, well, one of these will be slightly higher. Let's assume the top one. I've got 5 minus 1.4 over 1314. So equation will be 5 minus 1.4 for two diodes over the resistance, 2.74 milliamps. Again, take the maximum of the two, the 5. 5 minus 1.4 over R, 2.74 milliamps, and then 0 gives you 0. Now this allows beta IB, allows 274 milliamps to flow. I'm only trying to push 25 milliamps. So this one saturates, that one saturates, and the output is 0.2 volts. Number 4 is TTL logic. If I have 5 volts in, again, this current has a choice. It's 1314 ohms. This current has a choice. It goes left or right. Right is the easiest path to ground. So this is the path the current goes. The current then is 5 minus 1.4 over R. 2.74 milliamps. That is amplified by beta, so this is 2.74 times 3. And those two add together gives you 2.74 times 4, 10.96 milliamps. In terms of voltages, this is 0, 0.7, here's a diode, plus another 0.7, another diode, and saturated, 0.2 volts. Again, saturated in that I've got 10.96 milliamps flowing at I4. I allow 100 times that, 1 amp to flow. I'm only trying to push 25, so beta IB is more than IC, this saturates. Problem 5, this is like we did in the homework. I've got a TTL or 555 timer outputting a square wave. Here's my on-off control. If the output is 0, what happens? Well, If this is 1.8 volts and 4 volts, V plus is less than V minus, this slams low, gives you 0 volts out. When this is 0 volts, that makes this 0.7, current flows this way. This diode is off, this diode is off. If this diode is off, I have no current flow, this turns off, and the output is 5 volts. So what you should get is V1 is 0 volts, 0.7 volts at V2, 5 volts at V3, 0, 0. On the other hand, for problem 6, if this is 1 volt, V plus is more than V minus, I slam high. When this is 5 volts, this is 5 volts, now the current finds the easiest path to ground. It now goes right. And these two turn off. When it goes right, the current is your 5 minus 1.4. I've got two diodes in series divided by R, 2.74 milliamps. 2.74. That allows 274 milliamps to flow. I'm only trying to push 240. So take the smaller of the two. If the 240 wins, I'm saturated, and V3 is 0.2. For some people, this resistor was smaller, so that gives you more current. If this is, if R is bigger, and they have less than 2.4 milliamps, say 2 milliamps, in that case, this is the smaller between 240, when this is saturated, and beta IB, 200. In that case, you enter the active mode. This is 100 times I4. And V3, I have to calculate, it's 5 minus I times R. In that case, you're actually active. So that is quiz number 7 for ECE 320.